Hi students, today we will learn magnetic effects of current, class 12th physics, right? So first of all, magnetic effects of current. Magnetic effects of current means what? See, current carrying conductor. Suppose this is one current carrying conductor. So current is flowing like this. So therefore, around the current carrying conductor, there will be a magnetic field will be developed, right? So how the magnetic field will be developed? So because a moving charges are there, no? Therefore the charges are moving in this one now. So moving charges can also produce magnetic field, right? We studied in the part 1, please moving charges, no? Please check it my first video. So here current is flowing means charges are moving onto this one, no? So therefore moving charges will produce a magnetic field. How the magnetic field will be there now? So here there is a current is there. Suppose you have to take your right hand thumb rule. This is a current. So curling of the fingers in this way, like a concentric, circular concentric circles. No, the magnetic field will be generated, right? So this was observed by first Worsted experiment. No, later on development was taken place. So Biot-Savart-Law will gives us to determine the magnetic field of a current carrying conductor, right? So what is this Biot-Savart-Law? So Biot-Savart-Law, right? So this Biot-Savart-Law, what did he say? A current carrying element. Suppose there is a one current carrying element is there. So this one current carrying element, we will take it as like a current here now. So this is one current, right? So current is a scalar quantity. So here, but we will take it as current element. Therefore, small amount of element will take it now like a dl. So I dl is a current element now. This current element is a vector quantity. This current element will generate a magnetic field. So at any one point, no, at certain distance r, we want to calculate the magnetic field here now, right? So as per the Biot-Savart, no, what did they say now? The magnetic field which is generated at this point, therefore due to small element, no, dB is the magnetic field will be generated. This depends on what factors now? Depends upon directly proportional to I dl, I into current element now, right? Current element into, so the angle between this current element is there, no, the angle between them is theta. So it is sine theta and inversely proportional to square of the distance. So this was given by Biot-Savart-Law. So by using this one now, we can determine the magnetic field at a distance. So what is this one now? dB. So you can remove this proportionality. We can place one constant. So this constant, so is nothing but a mu naught by 4 pi. What is mu naught? Mu naught is nothing but a absolute permeability. So permeability means what? Therefore the magnetic field can also be able to pass through the vacuum, this absolute with the in the vacuum now, right? So for different medium, so magnetic field will be also different, right? So this is mu naught by 4 pi into I dl sin theta by r square. So this is your dB. So in this way, by using this formula, you can integrate it, no? You can calculate the magnetic field at any point. So this mu naught by 4 pi value, so you can calculate it, no? Right. Let us see. So we can rewrite this equation, no? Therefore dB, so vectorially we can write down mu naught by 4 pi into, so I is there, no? Therefore into dl, I can write it as like a r cap. So therefore dl cross r cap, right, by r square will be your so magnetic field. So right, in the vector form now. In this way, we can determine the direction. No, dl element is there. So dl element, this is a dl element. This is your r vector. So r cross b. Therefore, dl cross r will be your magnetic field. The magnetic field is into the board. Or you can determine by using another method. No, right hand thumb rule. So take thumb as your current element. So curling of the fingers is nothing but a magnetic field. Here the current element, no, current direction. So magnetic field will be, it is inward. Right hand thumb rule, we can use it now, right? So to determine the direction. So one more way we can write down. We know that r cap can be written as r vector by modulus of r. Sure. So therefore we can rewrite it as, so here now dB, so dB vector will be equal to mu naught by 4 pi into I into dl cross r vector divided by r cube. So this is in the examinations, no, may be asking. So these equations, no, please try to be careful on this. R vector means R cube, R cap means R square. Clear? So this is your magnetic field. So can be calculated by using the Biot-Savart law, right? So now mu naught by 4 pi. What is the mu naught by 4 pi now? So mu naught by 4 pi value, it is given as like a, that is mu naught value is nothing but a absolute permeability. So this it will be equal to 10 to the power of minus 7. Mu naught is equals to, so 4 pi into 10 to the power of minus 7. What is the unit now? So you can write down B. Okay. So mu naught by 4 pi dB is nothing but a magnetic field measured in terms of Tesla into R square by current into this one. No? So therefore Tesla, this is R square into meter square. So divided by current, therefore ampere into meter. So what you can write it now? So mu naught value we can write it as 4 pi into 10 to the power of minus 7 Tesla into meter by ampere. This is the SI unit of our absolute permeability. Right? So in one of your NEET examination they asked what is the dimensional formula for this absolute permeability. So we can rewrite it as, what is the dimensional formula here now? Dimensional formula of absolute permeability. First of all you should know magnetic field dimensional formula. Magnetic field unit is what? Force per ampere into meter. So this is Tesla is nothing but a force by ampere into meter by ampere now. Therefore you can write down force by ampere square. So what you can write it now? Force is nothing but a M1 L1 T minus 2 divided by therefore A minus 2. So this it will be your right dimensional formula for mu naught. Clear? So here by using this one we can determine magnetic field at any particular point now, right? So by current carrying coil now. Right. So students be careful on this one. No? So about the Biot-Savart law. Now we will go for another one more concept, no? That is one more law, that is Ampere's law. What is Ampere's law? Ampere's law. It is another one more form of law. It is used to calculate the magnetic field. So it is very easily just like modified onto this one. No? So what is this law now? Therefore there is one current carrying conductors are there. Therefore suppose I1 is there now. So this is suppose I2 current is there now. Suppose this is I3 current going downward direction now. So we want to calculate the magnetic field due to all these currents. For this one now, what you have to do? You have to consider 1 ampere loop. Therefore any one loop is like a loop onto this one now, right? So now this loop is closing all these current carrying conductors now. We want to calculate the magnetic field due to this one now. So this Ampere law tells that is line integral of B dot dl. So magnetic field due to into dot product of this dl, it will be equal to mu naught times of sum of the total net current onto this one now, which is enclosed by this Ampere loop. So therefore here how to write it now? How to apply this one now? You have to consider one loop now. So here what I was going to consider now, suppose I am taking this is at this point now. So this is your suppose it is dB. So right, so here we want to calculate it now. This due to this current it is dB, right? So also we will take it as like a dl. So this dl length it is there now. At this point, you see here is a current carrying conductor. Here it will be your magnetic field. Here only we will take it as like a dl onto this one now. So both are acting in the same direction now. Therefore theta will be equal to 0 cos 0. D dot product is there now, dot product. So cos 0 is nothing but a 1, right? So how you can rewrite it as now this formula integral. So b dot dl it will be equal to mu naught. So b dot dl will take it now mu naught. So here this current is there now, therefore this current. So as per your right hand thumb rule, therefore the magnetic field is in the same direction now, whatever you consider, that is to be taken as positive. I1, so this is a current now, therefore it will be in the same direction now, plus I2. So this is a current which is going now, therefore which is opposite direction now, so taken as I3. right? So you have to select, right? So as per this one, no? Then you try to, this angle between them is 0. So therefore B dl cos 0 is 1. No? So you can integrate the length of this, integrate the length of this, you can get the magnetic field due to this current carrying conductors now, right? So by using these two laws, we will determine the magnetic field of a current carrying conductors now. Very important laws now. Let us see what are these current carrying conductors, how to calculate the magnetic field. So simple thing, first of all, let us take infinitely long. Therefore, this is one current carrying conductor is there, so which is infinitely long current carrying conductor. So we want to calculate the magnetic field now. So therefore, at certain distance, at certain distance is r. We want to calculate it. So here for this one, we can consider one ampere and loop. Loop means here like a circular loop. I will take it now. I will take one circular loop. So then I will take it as here certain amount of dl length. I will take it now. This is a current. Therefore, along this dl length, so this side only here dB it is take place now. Therefore, dl is also in the same direction, dB also same direction now. Theta is equals to 0. So cos 0 is nothing but a 1. Then we can write down integral b dl cos theta, it will be equal to mu naught. Only one current is there, so that is also we are taking like a in our same direction now, mu naught into I. So this is cos 0 is 1. So b into integral dl. So mu naught into I. This integral dl is nothing but what? This length it will calculate. The length of this part, small element, total length it will be nothing but a circumference of this. So what you will get it now? B into 2 pi r will be your circumference of this into mu naught into I. R B is equals to mu naught into I by therefore 2 pi r. So this it will be your magnetic field due to one current carrying conductor now. Infinitely long current carrying conductor. How the magnetic field is there now? Magnetic field is directly proportional to current. Magnetic field is inversely proportional to the distance. How it will be there now? So it will be inversely proportional now. So you can rewrite it as our graph now. B and R it is inversely proportional now. Clear? This formula you need to remember compulsory in our coming topics now. We'll understand. This is magnetic field. So magnetic field, right, due to infinitely long current carrying conductor, right? Magnetic field due to an infinitely long current carrying conductor. So therefore, what is the formula? So B is equals to mu naught into I by 2 pi r, right? So similarly, now we understood no. Therefore, here remember that here only the logic is there, here only the technique is there. So we can write it. So this is infinitely long. What is the infinitely long now? So magnetic field is nothing but a mu naught into I by 2 pi into r. So this is infinitely long. Now what I will do? I will take it as semi-infinite. Semi-infinite means what? One end I know it, another end I don't know. This is semi-infinite, right? So this is infinite. So one end I know it, another end I don't know. So that means exactly half of this one. No? What you can get it now? That is nothing but a mu naught I by therefore 4 pi r. Half of this. B is equals to B infinite due to by 2. Half of this one, no, you can get it this answer. Clear? Very important formulas, no, semi-infinite, infinite. Now we want to know the formula for finite length. Finite length, very important, most important, no, remember this one. No? This you know it, okay? So this is your current, okay? Here also current is there. So therefore we want to calculate the magnetic field at certain distance. Keep in mind, no. So here you can take it here, no. Right. So therefore, if you know the angle here, no, alpha and beta, or if you know this one, no, theta 1 and theta 2, if you know any angle. How to write it now? See here, mu naught, this is infinite, no, if you take it here, no. So B is equals to mu naught into I by 2 pi r is nothing, 2 multiplied. So 2 pi r, therefore 2 multiplied, therefore it will be divided by 4 here. This 2, what I will do now, I will write it here, listen carefully. So if you know this alpha, alpha is nothing but along the length, no? Along the length is nothing but cos. Therefore cos alpha. Here also beta, therefore cos beta. Or we can rewrite it as, so same thing, mu naught into I by, so 4 pi r, mu naught into I by 4 pi r into, therefore here you know this theta is nothing but a opposite side of this one, no? Therefore sin theta 1 plus sin theta 2. Clear? So this it will be your magnetic field, so due to finite length. Clear? 9. Now, now we will calculate magnetic field due to certain geometrical shapes. No? Most important question. So most of the times in JEE mains, no, they ask this question. So be careful onto this. So most important. Therefore, we want to calculate the magnetic field due to one current carrying conductor of a square loop. So this is I, and this is I, this is I, so this is I. So we want to calculate the magnetic field at this point now. Most important concept, right? Clear? So how to do this question now? Very simple. See, always use right hand thumb rule. Right? Two ways you can use it, no? Right hand thumb rule. So you have to use thumb as a current. Curling of the fingers is your magnetic field. Or curling of the fingers is a magnetic field. Thumb it will be a here current carrying conductor is thumb. Curling of the fingers is nothing but a magnetic field. Or you can take curling of the finger as a current. So thumb as your magnetic field. So anyways you can rewrite it, no? Therefore you can use both the ways, no? So here this is a current, no? Current magnetic field here. It is inside into the board. So this is a current magnetic field inside. This is a current inside, right? Or you can rewrite it as, no, this current is flowing like this. I'll take this is your current. So magnetic field is inside, right? So this it will be your direction of your magnetic field. We want to calculate, how to calculate it now at the center. So how to do it now? Therefore, so totally length it will be equal to L. So what you can write it now? This distance it will be L by 2. So you know this is divided equally 45 degree. So this also 45 degree. Now this is due to is inside. Like that 4 parts are there. Magnetic field at the center it will be equal to 4 into due to B1. How much now? 4 into B1. B1 is how much now? We want to calculate B1. So just now we written no, mu naught I by 4 pi. What is the distance here now? Distance is nothing but L by 2 into 2, right? Into cos 45, cos 45. 2 cos 45. Clear? So this 2, 2, 4. This will be get cancelled out. So cos 45 is nothing but a root 2. Therefore mu naught I by, so pi into L into root 2. This is your B1. Clear? So like that. So it will be total due to all these 4 times of this. 4 times of mu naught into I by root 2 into pi into L. Therefore you can rewrite it as, simplify this root 2. 2 into 2 is there, no? 2 root 2. You can write down 2 root 2 mu naught into I by pi L. This is your magnetic field at the center. So this question in JEE mains, no, so many times it is repeated, right? So like this we can calculate the magnetic field. So due to this coil, right? Similarly, so even you can do as a homework, no? So one homework question you can do it, no? So as a practice question, so you can take it as your equilateral triangle. It is L, L, L. So therefore here equilateral triangle means 60 degrees there. We want to calculate magnetic field here, no? This is your current. You try it now. So right, and try it and please comment your answer. Okay. Now we'll do one more question, one more concept, no? See here. Now, so suppose here one current is there, no? Infinitely non-current carrying conductor it is there. So this is I1, like let us assume that 10 ampere. Now here is also one more current carrying conductor is there, I2. It will be suppose 20 ampere, infinitely long. So now we want to calculate the magnetic field at the midpoint. These two are separated by, suppose it was 20 centimeter. So midpoint at this point we want to calculate it A. So here also you can calculate, no, 10 centimeter, no. So here also you can calculate B. Here also 10 centimeter, no. So you can calculate at C. So magnetic field at A, B, C you can calculate it, no. So I'll do 1 or 2 questions, no. Remaining things, no, you can try it. So here I will calculate what is the magnetic field at A. At A we will calculate it. How to do it? Very simple one, no? Listen. So here this is a current, no? Current. So this is a current, this is a magnetic field. Due to this one, no? Therefore magnetic field is inside. Right? It is inside. And due to this one, no? Therefore here it is a current carrying like this. Due to this one, no? The magnetic field is outward. Okay? So due to this one is outward, due to this one is inward. Clear? So therefore here which one is greater? So here 20 ampere same distance, here 10 ampere same distance. That means definitely this current carrying conductor is producing the more magnetic field here, no? So net magnetic field at BA, so at BA, right, it will be, so magnetic field at A, it will be equal to B2 minus B1. Why? This is more, right? So what will be the answer now? It is will be infinitely long. So mu naught into current is how much now? 20 ampere divided by 2 pi, infinitely long, 2 pi into D is nothing but this D is nothing but 10 centimeter, 10 into 10 to the power of minus 2, minus, so due to this one, no, therefore mu naught into 10 divided by 2 pi into 10 into 10 to the power of minus 2. So what I can write it now? Therefore mu naught, therefore it will be, denominator is also same, numerator, therefore 20 minus 10 is nothing but 10. So net will be equal to mu naught into 10 by, therefore 2 pi, this to 10 to the power of minus 1. Clear? So therefore you take it now 100, no? So mu naught by 2 pi is nothing but 2, I mean mu naught value is how much now? You can rewrite it as 4 pi into 10 to the power of minus 7. This I am taking here now 10 to the power of 2 divided by 2 pi. Get cancelled out, no? It is 2. So 2 into 10 to the power of minus 5 Tesla. This is your magnetic field at A. Clear? So similarly, you can try it, the magnetic field at B. How to do it now? Magnetic field at B. So at B, this is your current, no? This is your current. The magnetic field at this point is outward. And this one, no? Magnetic field at this point is outward. Therefore, both are coming outward. You need to add it. So here, therefore magnetic field is inside. This one, magnetic field inside. Both it will be, you have to add it. Clear? So I will do this one, no? You do this concept, no? Right. So B at C, magnetic field at B at B, no? We want to calculate. So you see here, no? This one, no? Current is outward. This one is current is outward. That means, so therefore due to 1 plus due to 2. So what will be the magnetic field due to 1 now? This is 10 centimeter. So mu naught into 10 ampere divided by 2 pi into 10 to the power 10 into 10 to the power of minus 2. Correct? Plus due to this one, no? So mu naught into 20 ampere divided by 2 pi into 10, here no, distance. What is the distance here no? This is 30, not 10. Therefore 30 into 10 to the power of minus 2. Right? You can simplify, you can get your answer on this. Okay? Similarly, try to calculate the magnetic field at this point. Clear? Now, this is one of your NEET question. No? Suppose, here this is your NEET question. What is given now? This is one infinitely long current carrying conductor is there. Suppose current is I. So, therefore, here, this also one infinitely long current carrying conductor is there. This at a distance r at r. We want to calculate the magnetic field at O. At O. What is the magnetic field? This is two infinitely long current carrying conductors. What are they? This one, no? It is inside. So it is into means it is inside into the board. This is your direction of your current. So this is your magnetic field at this point, right? So like this, it is going to infinity like that. It is backside going to that infinity. Clear? So therefore this is a current, no? So magnetic field at this point, it will be toward this side. And this also it is infinite, therefore this is a current. So the magnetic field at this point it will be upward onto this. Clear? So therefore, right? So the magnetic field due to this one is upward. How much now magnetic field here now? B is equals to mu naught into I by 2 pi r, infinitely long. So mu naught into I by 2 pi r. How it will be there now? This side it will be the B. So this side is also B. So therefore 90 degree. So resultant it will be equal to root 2 into B. Therefore, magnetic field at O is nothing but a root 2 into B value. B value is how much now? Mu naught into I by, therefore 2 pi into R. So this will be root mu naught I by root 2 into pi R. This is your magnetic field at this point. This is your one of your NEET question now. Clear? Like this, you can expect the more number of questions no on this one now, right? So one more question. So for Biot-Savart-Law, okay. So I mean Ampere's law. Okay, students. So right. So we discuss some of the applications. No. Now in next part, no, we'll discuss regarding the circular parts, no, circular ring, and then combinedly we will do as like a one more part, like totally 3 parts we will do it, no, based on this. So based on this only Biot-Savart-Law and Ampere's law applications now. Okay, students. So thank you for watching. So please watch part 2 of this video now. Thank you.